Definitions and basic concepts. Readability. This term indicates the closeness with which the scale of the instrument may be read. For example, an instrument with 30 cm scale has a higher readability than that of a 15 cm scale. Least count. It is the smallest difference between two indications that can be detected on the instrument scale. Range. It represents the highest possible value that can be measured by an instrument, or it is the difference between the largest and the smallest results of measurement. Data. Elemental items of information obtained by experimental means assumed to be in numerical forms. Population, also called universe, a collection of data either from finite or infinite in number, all representing the same quantity. Sample, a portion of a population represent the time value or should be a representative of the population. Multi-sample test, a repeated measurement of a given quantity using altered test conditions such as different observers or different instrumentation. Merely taking repeated reading with the same procedure and equipments does not provide multi-sample results. Example, many experimenters have conducted experiments to determine the velocity of light in vacuum. This has been done using different apparatus and techniques. Each leading measured is supposedly a unique quantity. Although the results vary, taken together, these findings are multi-sample tests. Single sample test, a single reading or succession of reading taken under identical conditions except for time. True value or actual value VA, it is the actual magnitude of the input signal to a measuring system which may be approximated but never truly be determined. The true value may be defined as the average of an infinite number of measured values when the average deviation of the various contributing factors tend to zero. Indicated value Vi, the magnitude of the input signal indicated by a measuring instrument is known as indicated value. This is the supply of raw or directly recorded data. Correction, it is the revision applied to the indicated value which improves the worthiness of the result. Such revision may be in the form of either an additive factor or a multiplier or both. Result VR, it is obtained by making all known corrections to the indicated value. VR is equal to A into Vi plus B, where A and B are multiplicative and additive corrections. Discrepancy, the difference between two indicated values or results determined from a supposedly fixed time value. Error, it is the difference between the true value Va and the result Vr. Error is equal to Vr minus Va. Accuracy, the accuracy of an instrument indicates the deviation of the reading from a known input. In other words, accuracy is the closeness with which the readings of an instrument approaches the true values of the quantity measured. It is the maximum amount by which the result differs from the true value. Accuracy is equal to maximum error is equal to Vr max minus Va. Accuracy is expressed as a percentage based on the actual scale reading divided by full scale reading into percentage of accuracy based on reading is equal to Vr max or min divided by Va into 100 into Va. Percentage of accuracy based on full scale reading is equal to Vr max or min minus Va by VFS into 100. VFS maximum reading, the measuring system capable for the particular setting or scale being used. Also, accuracy is based on the limits of application. The cost of the system increases rapidly if increased accuracy is decreased. The limits should be made as wide as possible. Further, a system cannot be accurate 100% at all times because an error is required to initiate the corrective action. Example, 100 bar plus or minus 1 bar, that is 100 bar pressure gauge having an accuracy of 1% would be accurate within plus or minus 1 bar over the entire range of gauge precision. The precision of an instrument indicates its ability to reproduce a certain reading with a given accuracy. In other words, it is the degree of agreement between repeated results. Precision data have small dispersion, spread, or scatter, but may be far from the true value. A measurement can be accurate but not precise, precise but not accurate, neither or both. A measurement system is called valid if it is both accurate and precise. First diagram, low accuracy, high precision. Second diagram, high accuracy, low precision. And third diagram, high accuracy, high precision. Difference between accuracy and precision. It is the closeness with the true value of the quantity being measured. It is a measure of reproducibility of the measurements. The accuracy of measurement means conformity to truth. The term precise means clearly or sharply defined. Accuracy can be improved, precision cannot be improved. Accuracy depends upon simple techniques of analysis. Precision depends upon many factors and requires many sophisticated techniques of analysis. Accuracy is necessary but not sufficient condition for precision. Precision is necessary but not a sufficient condition for accuracy.